Hi everybody. Today we are going to continue with specific exercises making use of permutations. Permutations, we have learned, involve ordering n elements, and n elements can be ordered in n factorial ways. So let's see what is our first problem. The first problem involves the letters of the word number. And the first question is, how many ways can you order the letters of this word? And the answer, everyone knows, is 6 factorial, which is 720. The second question is that I am going to stick together 3 letters num, so they cannot move among each other, or they cannot move as separate units. And now the question is, how many ways can I arrange the remaining 3 letters B, E, R, and this bunch of letters num all together? One way to solve this exercise is to calculate the possibilities. Since there are not that many, it's a viable way of solving the exercise. So considering num, it can go either here, or here, or here, or here. 3 letters determine 4 possible slots. So that's going to be 4 possibilities. And don't forget that the letters B, E, R are separate units, so they can permute among themselves, they can choose their own order. So altogether it's going to be 4 times 3 factorial, which is 24. However, there is a quicker way to calculate the possibilities. Namely, if this is anyway 1 unit, then altogether you can reformulate this problem. You can think about this problem as ordering 4 units. So your story, your alternative story, can be 4 factorial, since I have to order 4 units. In cases of combinatorics, in problems concerning combinatorics, it's always very useful to think about your story. Formulate the problem in such a way that maybe you can simplify your calculations. Today we are going to see some further examples where there are 2 alternatives and one is simpler than the other. Okay. Next problem involves 5 people. As in mathematics, it's quite common. We designated the 5 people with 5 capital letters. I could think of names: Anne, Bill, Cecile, Don, and Anil, but let's just remain with the letters. They go to the cinema and they want to sit next to each other, so the possible sitting arrangements are 5 factorials. But life is not that easy, because Bill knows that Cecil always eats his popcorn, so he definitely doesn't want to sit next to him. Therefore, they want to sit separately. So the question is, how many ways these 5 guys can sit down if Bill and Cecil don't want to sit next to each other? Well, there are quite a few possibilities. Remember that we started out with 120, and some of them are going to be bad and some of them are going to be good. So let's start with an alternative idea, which is again useful here, namely calculate the bad cases. Where the bad cases for us constitute those cases when Bill and Cecile definitely sit next to each other. So coming back to the idea of the previous exercise, let's consider them a unit. If we consider them as a unit, we can calculate either this way or this way. Problem. First one, I'm going to show that one now, but later you can automatically choose the simpler one. So we have 3 guys left. 3 guys, as we know by now, constitute 4 possible slots. So Bill and Cecile can sit together here or here or here or here. That's 4 possibilities, but we are not ready with that because unlike in the case of the fixed order num, here Bill and Cecile can switch places among themselves in every possible slot. That's a possibility. So therefore you have to multiply by 2, and when we write down solutions of permutation problems or combinatorics problems, please make sure that you justify your calculations. So with small hint words we write down that this is because they can switch places, and this was because of the 4 possible slots for them, 4 possible places for the unit B and C. And finally, we have one more possibility to consider, namely, these 3 guys also can order the placement among themselves. They can sit in any possible order, so that gives us 3 factorial. So that's ordering, permuting A, D, and E. So our final result is 48. The alternative story would go, let's consider BC as 1 unit. So then I have to order A, D, E, 3 units, plus BC, that's 4 units. Ordering them gives me 4 factorial. BC can switch places, so I have to multiply it by 2, and this gives me 48. Don't forget that we are at the bad cases of the original problem because Bill and Cecile don't want to sit next to each other because of the popcorn problem. So how do I calculate the favorable cases? The cases when Bill and Cecile don't sit next to each other. I subtract the bad cases from all possible sitting arrangements. So basically from 120, I subtract 48, which gives me 72. And the answer is there are 72 ways these 5 guys can sit next to each other if Bill and Cecile don't sit next to each other. Okay, let me clear the board and let's move on to some number problems. Okay, so the first problem is we have number cards 0, 1, 2, 3, and 4. These are my number cards. Then I want to create a 5-digit number so that I use each card exactly once. Since it's a number, a 5-digit number, therefore, you have to make sure that the first digit is not 0. Since this is an important condition, because then it wouldn't be a 5-digit number, you have to start with that consideration. So how many numbers can you put in the first slot? Only 4. If I put it with an arrow and then the number, that means the possibilities. If I put a concrete number on the slot, that means that that number goes there specifically. Now, I chose one of the numbers. Let's say I put here 2. I have 4 cards remaining, and now 0 comes back into the story since it can happily go into the second place. So again, I can choose from 4 cards. Let's say I put there 4. And then I have remaining 3 cards. I can choose any of them. Let's say that 0 came now. That's spot. And then the remaining 2 and 1 go into the last 2 slots. So the final answer is 4 times 4 factorial, which is 96. So there are 96 5-digit numbers out of the cards 0, 1, 2, 3, 4. Maybe you wonder whether you could do this in any alternative way, and yes, you can. Because you could also say that I don't care I calculate all possible 5-digit codes, codes being distinguished from numbers because 0 can go into the first place. That's going to be then 5 factorial, since 0 can go there. And then the bad cases are all those chords which start with 0. How do I calculate that? Well, in this specific case, 0 is fixed there, so I have only 4 slots to fill, and I am choosing from 4 possibilities, then 3, then 2, then 1. So that gives me 24, 4 factorial. Therefore, the correct answer is, for the original question, all codes 5 factorial, and subtract from that the bad ones, which start with 0, which was 4 factorial, and that is 120 minus 24, which gives us 696 cases. We are happy to establish that the two ways of solution led to the same final result. Okay,